Okay, for what we have regarding the domain of a function, and we have with the rule of thumb, for a function y is equal to f of x. Again, f of x is a functional notation for what we otherwise say is going to be y. We have by definition for the domain of a function, we have to be the set of all values of x such that the function is a real value. And looking at determining the domain of a function, and we're going to express the domain in interval notation. Now we have at the start, we have first case we have f of x is equal to x plus 3, and here we have a linear function. And if you notice, we don't have a fraction or an even root radical, and again we are sticking to the real number system. And for f of x equals x plus 3, and you can plug in anything for x, whether it's 0, negative, or positive. So for this particular function, we don't have any restrictions. And if the function has no restrictions, then what this would signal, I'm going to put this down once, is that for the domain, you're going to have the set of all real numbers. If you have no restrictions, so you have all real numbers. And if I express in terms of interval notation, we have for f of x is equal to x plus 3. And symbolizing what we have for the set of all real numbers, again, you have in parentheses, you have continuity between negative and positive infinity. And again, infinities are boundless, so we use parentheses throughout. Okay, now for what we have in the second function, we have for f of x is equal to x squared plus 4x minus 7. Again, you can plug in 0, a negative value or positive value, and still have something to come out defined in the real number system. And just like the linear function right before it, this quadratic function also has no restrictions. And so we have, in the case of the domain, we have the set of all real numbers. And again, we have an interval notation. You still have running between negative and positive infinity. All right. Now, in the third case, we have f of x is equal to 5 over x minus 9. Now, we have for fractions, now for fractions to be defined as a real value, the bottom part cannot be equal to 0. So there is a restriction, and this will be the x minus 9 cannot be equal to 0. And if x minus 9 cannot be 0, we have that x cannot be equal to 9. So we have an interval notation. Again, we have one value that is left out, and of course that is going to be 9. So the domain is going to be consisting of all the values in x that will be less than 9. And again, we have parentheses around the negative infinity and the 9 to indicate that 9 is not included. And then we have those values of x that will be greater than 9. And so completing out what we have in the interval notation for the entire domain, we have those values greater than 9. So we have parentheses around 9 and infinity. So this part is for less than 9, and that part is for greater than 9. And in the case of what we have for f of x is equal to x plus 2 over x squared minus 16. For this one, we have x present in both the numerator and denominator. But again, we're keeping the rational expression defined. And again, the restriction is going to come from the denominator. And again, you can have a 0 numerator as long as you do not have a 0 denominator. So in this case, the restriction will come from x squared minus 16, again, which cannot be equal to 0. And here we have a difference of squares. And if we look at factoring x squared minus 16, all right, neither factor, x plus 4 nor x minus 4, can be equal to 0. And so for this function, we're going to have two restrictions. And we have from x plus 4, x cannot be equal to negative 4. And also from x minus 4, x cannot be equal to 4. And so we have for the domain, and the more restrictions you have, the more subintervals you're going to have formed. So we have for the exclusion of negative 4. Now we're going to have the set of values x that will be less than negative 4, indicated by this first part. And you'll have those values of x between negative and positive 4. And so we're going to have a middle interval section with parentheses that will surround both negative and positive 4, still symbolizing that negative and positive 4 are excluded. And then we have for the rest of the set, we're going to have those values of x that will be greater than 4. And so we have parentheses once again. Now, along with rational functions, we have radical functions. And we have f of x is equal to the square root of x minus 17. And in this one, okay, we have an even root radical. And again, in the real number system, we cannot have an even root radical of a negative value. So we have for x minus 17, okay, this one cannot be negative. And to symbolize, okay, what we have here. So if x minus 17 cannot be negative, now it can be 0 and it can be positive. And as an inequality, we can say we have x minus 17 is greater than or equal to 0. And now for the set of values x, we had to be greater than or equal to 17. And we have for the domain, in this particular case, and expressing in interval notation. So we have 17 is included. So with the equal sign in the inequality, we have in the interval notation, the bracket is going to go around 17, and the rest of the values you have going upward, approaching infinity. Now, in the sixth case, now we have the square root of 8 minus 2x, and just like x minus 17, 8 minus 2x cannot be negative either. And if I go ahead and set this up as an inequality, we have 8 minus 2x is greater than or equal to 0. And if I isolate the x term, so if I take away 8 from both sides, okay, so you're going to have that negative 2x is greater than or equal to negative 8. And again, so we have back in the scenario dividing by a negative. And with division by negative 2, I'm going to change the direction of the inequality. So again, if I multiply or divide by a negative, the direction of the inequality is going to change. So here, we're going to have the x is less than or equal to 4. And we have the, with this restriction, okay, again, we have the x is less than or equal to 4. And if I symbolize the domain in interval notation, so we have going from negative infinity, approaching and including the value of 4. And so this is how that will appear. Now, for this remaining case, if I have an expression that is both a fraction and that which consists of an even root radical, okay, now, in the case of 2x minus 6, okay, because we have a square root, okay, 2x minus 6 cannot be negative. And also, what we have regarding 2x minus 6, okay, 2x minus 6 is in the denominator position. Okay, so 2x minus 6 cannot be 0. So that means that can't be negative, can't be 0, so 2x minus 6 must be positive. And if I take what I have here and express in inequality terms, okay, so if 2x minus 6 is positive, well, we're going to have 2x minus 6 is greater than 0. And if I add 6 to both sides to isolate the variable term, so we're going to have that 2x is greater than 6. And we have a division by 2. And since I'm dividing by a positive number, the direction remains fixed as greater than. And we have for the inequality solution, we're going to have the x is greater than 3. And expressing the domain in interval notation, it's going to follow that for the lower limit, that is going to be greater than 3. and tangent to it. So 3 is not included, so we have parentheses throughout. So we have going past 3 and heading on out to infinity. And that is going to be, once again, the domain of this particular expression.